So we just discussed how additional funds needed can identify the level of assets that will be required in the coming year as a result of sales growth. Another way we can determine this level is to use historic data as a predictive model for the future. Our financial calculator has the ability to run a linear regression on a set of data. If we believe our data has a linear relationship, we can use this regression to make a forecast about the value of some category in the future, something on our income statement or our balance sheets. So let's look at an example. The following table shows that sales and inventories for a firm over the past 3 years. So we have years 1, 2, and 3. Sales in year 1 were $10,000 and inventories were $2,500. In year 2, sales were $11,500 and inventories were $3,250. And in year 3, sales were $12,500 and inventories were $3,800. So the question is, use a linear regression to predict the inventories in year 4 if sales are projected to be $14,000. So a linear regression really is just what you would have an intuitive understanding of about a line of best fit. So here we have 3 points of data. Each point of data has a level of sales and inventories. If you were to graph these 3 points on a graph with sales and inventories on the axes, and you were to draw a line through them of best fit, that's kind of the idea behind the linear regression. Then we're given a level of sales and we're trying to predict a level of inventories, so it would be like going to $14,000 on the x-axis, going up to your line of best fit and reading off the y-axis, the inventories, what it would be. So that's kind of the intuitive idea behind a linear regression. But let's see how to really do it. So recall a linear regression is an equation. It's just an equation, and it has this form, y equals a plus bx. It's just your standard idea of a line with 2 variables in it. The variable y is what we're predicting, and x is what we're basing it on. Sometimes we call y the dependent variable and x the independent variable, because y depends on x. So we'll input the inventories in our calculator as the y variable, because remember the question is asking us to predict inventories, and we'll input the sales as the x variable, because x is the independent variable. Sales don't depend on inventories, it's the other way around. You adjust your inventories based on the sales that you expect to have. So that's why we input inventories as the y variable and sales as the x variable. To enter the data in our calculator, we enter the x values first. Remember, x is sales. Then we press input. Then we enter the y values, the inventories, and then we press sigma plus. Sigma plus, this Greek letter sigma, it just means you're adding it. So you're just telling the calculator that you're adding these data points to a registry in the calculator, and once you're done, it will know to use those data points to construct this linear regression. So this is the process we go about adding these points to our calculator. So let's do it. The first data point is $10,000 for sales. Remember, we enter that first, the x data, the independent variable, sales. So we put 10,000, we press input, then we press 2,500, the y variable, inventories, and then we press sigma plus. That tells the calculator we're done with the first row of data, and we just move down the table. The second year, sales are 11,500, input, 3,250, sigma plus, and finally 12,500, input, 3,800, sigma plus. And that's all of our data points. So now that the data is in our calculator, to find out the predicted value when sales are $14,000, we just need to press the following combination of buttons. We press 14,000 to tell the calculator that we're grabbing that 14,000 on the x-axis as if we were looking at the line of best fit. We're telling it we want to predict what happens when sales are $14,000. Then we press shift, and then we press this button, y hat, comma m. That's the button that represents y hat, the predicted value for the y variable, which in our case is inventories. And that gives us a value of 4567. So that's the predicted value based on this regression, based on this historical data for what inventory will be when sales are $14,000. Well, sometimes we don't even need to use a regression to forecast required asset levels. We may be given the growth rate of a firm's sales which we can then use to find the balance of a certain asset category that is required to sustain that growth. So sometimes you don't have to use a regression. Sometimes you don't have to go through the whole process of finding additional funds needed. You just have to use the data that is given to you in the question and find out by how much some category would have to increase to make sure that you're going to be all right for your sales growth that you anticipate for next year. That's the whole idea behind this forecasting lesson. So for example, suppose a firm currently has $500 of fixed assets, which are operating at 75% of capacity. If sales last year were $2,500 and are expected to grow 40% over the coming year, by how much must fixed assets increase to sustain the growth? So first, let's find out what level of sales our current level of fixed assets could sustain. So since $2,500 of sales were made at 75% of capacity, so you're using 75% of your fixed assets and you're generating $2,500 worth of sales, the amount of sales that could be made at max capacity, well, we just need to set up this equation. We know that 80% of our max capacity, whatever it is, we're just leaving a variable, max, because we're solving for it, equals the $2,500. If we solve this for max, we divide the 80% by both sides, and we see our maximum capacity is sales level of $3,125. So since $500 of fixed assets can generate a maximum of $3,125 in sales, the firm's target fixed asset to sales ratio is, we just divide the two. The fixed asset is $500, the sales is $3,125 at the maximum capacity, that's 16%. So basically this is saying that when the firm buys these fixed assets, it knows how much, it has some knowledge about their maximum ability to produce, the maximum capacity that they could produce and turn around in sales. And so there's this ratio of 16%, and basically the idea is they want to keep that ratio. Whatever sales growth they have in the future, they want to make sure they match the fixed assets to 16%. And basically it's so they have a buffer zone, they have some area in between. We saw that they were originally producing at 75%. It wants to keep some buffer zone, so it has this target ratio that it has, and this is what we're going to use to find out how much it needs to increase these fixed assets to sustain this new higher level of sales. So that's the idea. So now let's find the projected sales level for next year. And we were told that it was going to grow by 40%, and sales last year were $2,500. So 2,500 times 1 plus 40%, which is 1.4, gives us projected sales next year of 3,500. So we have a target fixed asset to sales ratio of 16%. Sales next year are projected to be $3,500. Well, now we can find out what we need fixed assets to be. So we want to maintain the fixed asset to sales ratio. So we say fixed asset to sales is going to equal our target 16%. We plug that 16% in for our target. We plug in our sales next year of $3,500 in for sales, and we just want to solve for fixed assets. So we multiply both sides by 3,500, and 3,500 times 0.16 gives us fixed assets of $560. So that's the dollar amount of our fixed assets that we're going to need next year to maintain this ratio. So fixed assets must increase by 560 minus 500, which is $60 worth. And that's the end of part 2.